Hello and thank you for joining the session. I am Amit and I will be discussing the benefits and challenges of using computation notebooks as co-design tools. Before presenting the findings of our CHI paper, I would like to quickly refer to a previous co-design project that we conducted. There are two key takeaways that are relevant. Firstly, participants with type 1 diabetes experienced difficulties in co-designing systems that met their individual self-care needs as part of co-design activities. Secondly, HCI researchers and data scientists found it challenging to apply co-design outcomes to data-driven machine learning activities. These key findings informed our work on exploring computation notebooks as co-design tools. Now, people from diverse professional backgrounds increasingly use computation notebooks to explore and visualize data. What makes computation notebooks promising is the combination of code, text, and multimedia resources in a single document. This made us ask, what are the perceived benefits and challenges of using computation notebooks as co-design tools to inform the design of machine learning models with end-user groups and type 1 diabetes care? To investigate this question, we conducted 5 online workshops in 3 separate groups, one with young adults living with type 1 diabetes, one with family members, and one with clinicians. We conducted online workshops and used Jupyter Lab to provide a web-based environment to work with code consoles, terminals, and Jupyter Notebook. We designed a notebook that explained how an example machine learning model predicted risk from hospitalization due to adverse health events, such as too high and too low blood glucose levels. We applied a holistic and incremental explanation and design approach. For example, the first part of the notebook aimed to understand participants' self-care experiences and roles of data-driven technologies. An example question that we asked as part of the workshops was, what are your thoughts on diabetes technologies that make predictions? The second part of the notebook showed a subset of the type 1 diabetes exchange dataset to exemplify a dataset and its potential limitations. For example, we asked, how do you think that representation could affect any predictive technologies using this data? The third part of the notebook explained how machine learning models make use of data to make predictions and introduced terminology such as features and labels and machine learning concepts such as training and testing phases. As part of the third workshop, we encouraged participants to ask any questions regarding what a machine learning model is and how it makes predictions. The fourth part of the notebook presented an interactive risk score visualization to exemplify how machine learning model features can influence machine learning model outcomes. We can see that changes to features such as HbA1c can adversely influence the risk score. As workshop facilitators, we asked questions such as, how would you describe your experience using the risk score? And what are your thoughts on assigning a health risk level to a person? Now let's have a look at the last part of the notebook. We revisited the feature importance plot of the example machine learning model. It shows that the most predictive machine learning model features are HbA1c and kidney function. We showed participants how they could create a fictional feature importance plot by changing the values of 2 arrays. Participants could add features such as carbs, stress, and sleep, and also change the feature importance to express their needs. Now, what are the key findings? We identified the following challenges of using computation notebooks as co-design tools. The technical user experience of the computation notebooks led in some cases to power imbalances and information asymmetries. For example, the user interface design was unfamiliar for many participants and initially impeded their roles as co-designers. Furthermore, we found that a one-size-fits-all approach to explaining machine learning did not meet people's individual information needs. We also identified benefits within this context. Participants used their computation notebooks as support tools to individually develop ideas and then engage in collective conversations. The notebooks were used as a ticket to talk about sensitive topics, with control over concealing and revealing personal experiences. Furthermore, participants were able to anticipate potential benefits and harms of the example machine learning model. However, all participants felt that the emotive nature of the terminology risk could potentially cause emotional distress when presented to young adults and family carers outside clinical settings. Furthermore, the notebook scaffolded step-by-step learning and supported participants who were non-data science experts in learning how to adapt existing code. Let me offer an example. One young adult created the following feature importance plot, including features such as blood glucose levels, carbs, exercise, hormones, and sleep. She described how the last co-design activity supported a sense of achievement. Quote, "For me, I had a couple of issues at the start. As I got into it, I picked it up pretty quickly. I felt really proud of myself. I can work a computer, but coding, it's something that I've never thought of I would be able to do. Actually, it's not as imitating as you think it is." These are the fictional machine learning model features that participants co-created. We can see that the example machine learning model is at odds with participants' fictional features and their holistic lived experiences. For example, one participant expressed her frustration with stigma at schools, where teachers were not aware of the differences between type 1 and type 2 diabetes. These findings highlight the importance of taking a holistic view and considering people's lived experiences and concerns when developing health technologies, including the implementation of machine learning models. Now let's conclude. A lack of domain expertise and end-user feedback can adversely affect machine learning model life cycles right from the onset. Our co-design work with young adults living with type 1 diabetes, family carers and clinicians exemplifies how computation notebooks can be used as co-design tools at early machine learning model development stages. To explain machine learning concepts with static and interactive data visualizations, to foster discussion on potential benefits and harms of a machine learning model, and to collaboratively inform the design of human-centered machine learning models. A promising research direction is to design more inclusive research support tools that can bridge machine learning and co-design processes.